Okay, so chapter 6 covers pretty much these three main loops. Okay, the while loop, for loop, and the do while loop. Okay, the nest loop here, I mean, this is not really a loop. It's just how you can actually nest another loop inside another loop, and just like you can nest an if inside another if, and so on. Just different ways that you can actually embed another loop inside another. That's all. But let's talk about the while loop here. So the while loop looks like this. I'm going to go and create a project in here. This will be a new project, and we will call this, it'll be unit 6, right? So unit 6. And we'll create a class in here. We just call this we'll call it the just loop is fine. The loop class. Just the main method here to create the loop class. So the first thing we're going to do here is the while loop. Okay, this is what's called a pre-test loop. Okay, because we test condition at the top. Okay, and pre-test, so there's a post-test loop as well. So the while loop is a pre-test loop, and the syntax for that is again, it will be very similar to if you learn JavaScript or PHP or Visual Basic, or most languages have the same structure here. So takes a keyword while followed by a condition wrapped inside a pair of parentheses, and then your curly braces. Okay, that's the syntax how to write a while loop. You test the condition in here. The condition is like your if block, right? If A is equal to B, or if something is equal or not equal to something. So this is a truth test. Okay. So usually when you do something like this, you want to test for a certain condition is true. So let's just say, for example, if we add a variable here of int type A, and we'll assign A with, I'm going to change A to something else. I is usually very popular. I is 0. Okay. And let's just say I want to use this while loop to print the i's, the value of i's, x number of times. Okay. So you would put in here the condition in here. So typically, let's just say if I ask you to print I from 0 to 10 using the system out, right, you will write that 10 times. Okay, I will be 1, I will be 2, and 3, and 4, and so on. So you have 10 statements here. In the while loop, you just say while I is less than, if it's including 10, inclusive, let's just say inclusive 10. So we're printing from 0 through 10. Okay, inclusive is the equal sign, right? Less than or equal to 10, if that is true. If this condition is true, then execute these statements in here, the body of the loop. Okay? So this is the condition. We're testing this condition. That's why it's at the top. This is the top of the loop. The bottom is right here, line 13. Okay? So I is 0, and I it is less than or equal to 10. That's true, so therefore it will go into the body of the loop. And then we need to, let's just say, system out in here. System.out.print I. Okay. So I is 0, that's true, less than equal to 10, print it out, and then it goes back to the end of the loop here, then it goes back up again to the line 10, repeats the loop again, until this condition becomes false. If it doesn't get to the false part, this loop will run forever, right? So you end up with having what's called an infinite loop, or a forever loop, and then it will use all your system resources, and then eventually will crash your system. And the only way to do that is just to shut down the program. If you can't shut it down, reboot your system, right? So you have to be careful when you do. You want to make sure you don't run into this kind of issue here. And so now, if I run it right now the way it is, it's going to an infinite loop, because there's no way to have this I to be greater than 10. When I is greater than 10, that's the only time when this loop is false. It will kick out of this loop when I is greater than 10, right? So how do we make I to go to be greater than 10? Yeah, it's adding, right? Yeah, I plus plus. Not that equal what? Plus plus. Keep adding 1 to itself until it reaches 10, 11, then it will get out of the loop, and then we're done. Okay, so the first time it comes through is 0, print 0 out, then we increment it to 1, then it goes down to line 13, nothing here, so it jumps back to the line 10 again. A test condition at 1 is less than or equal to 10, yes. Then we go into the body of the loop, print it out, print 1, and then you increment that to 2 now, and you keep doing that 10 times, 11 times. Okay, so if I click save now and run this file, you see that it should print 10 times, from 0 to 10, including 10, because we say inclusive here, the equal sign. If you take the equal sign out, it will be just 0 through 9. Okay? So very, very efficient, very convenient to use loops to do this repetition stuff. Okay? Especially when something is like so similar, and all you do is just change one item at a time. So instead of having to write this 10 times or 100 times, I use a loop to do that. Okay, use a while loop to do this when you don't know the limit. Usually you don't know the limit here. Here we just say, oh, I know it's 10. I want to stop it at 10. But what if you don't know what that 10 is, right? So whatever that maximum is, you want to receive a variable called, int max is equal to, when you read that from the input, for example, right? You could say something like this. Instead of having so the max could be 10, and then here just say put max here, right? So while I is less than max, and that still be the same thing, you'll get the same result, 0 through 10. So here I'm not putting the numeric literal in here. I use a variable name, and I'll change the value here. But it's 10. I know that 10 because I see it there. What if you don't know, right? So let's just say that we would do this. Scanner input, new scanner. We'll read it from the user keyboard. Okay, so I'm going to just add this class. So in here, instead of 10, I'm going to put input that next int. Right? So reading from the keyboard, and however that, whatever the number is, it's going to be used for the max, and then we'll have that many lines printed out. So before we read that, I want to put a system out here to tell the user to enter a positive number, right? You don't want a negative number. If you do a negative number, then you have to adjust your condition here. So just say positive number. So when I read this line, it's going to ask for a positive number, enter the number, hit enter key, and then it's going to come into the max, and it will print that many times. So if I execute now, it's asking for a positive number. If I put 50, it's going to print 51 times, including 0. Okay? So as you can see, it prints all the way 0 all the way to 50. Right? So in this case, you don't know the maximum value. So you use a while loop to do the loop if you don't know the maximum. I mean, it's not always true, but you can also use the for loop to do it, which is fine. You still need to read the value of the max value. But typically, the while loop is for that purpose. Okay, so you test the condition at the top. And then if this condition is true, and only if it's true, then it will execute the statement in the body. Otherwise, it won't do it, right? So if I were to put, like, for example, if I put like 10 for the I, let's say my initial value is 10, okay? And if I run this again, and I enter a value of, let's just say 12, then it's going to print 10, 11, 12 because I'm starting from 10. Now if I run it again, if I enter number 7, then nothing gets printed because 10 is not less than 7. So therefore I don't have these two lines executed. So there's a possibility that the loop may not get, the body of the loop may not get executed, okay? Because we test the condition at the top, right? So that's the while loop. Any questions on the while loop? Okay, so let's do the next one. This is the do while loop. Okay, this is what's called a post-test loop. We test condition at bottom. Okay, it's just the opposite of this one here. Opposite of this. So we have a do while loop. And also what I put here, it says guarantees one iteration. Okay. It will loop through this loop one time, guaranteed. Whereas this one here, it may not loop through if this is false, right? So you just saw that if I put a 7 as the input for the user, it's false, so it doesn't print the data in here because the initial value was 10. Okay, so it's not guaranteed one loop through. But this one will guarantee it. So the syntax is you put a do on the top here, and then you put in the curly braces. Oops. And then you put the while down here after the curly braces, followed by your condition. Okay? It looks a little bit different. And then you put the condition right in here. So you can say I is less than equal to max. And then, so you test at the bottom of the loop. This is the top, and this is the bottom. So in between here will be your statements. The do while loop. Post test and guarantees one iteration. That means it will run through this code lines to 24 all the way down to line 27. So whatever your code you put in here will run. And then we'll test the condition at the bottom here. If this is true, if the condition is true, then it will jump back to line 24 and start again. So you'll loop through this loop this way. And then if it's false at the first run, then it will exit out. But by that time, you already loop it through one time, right? So it's guaranteed one time. So if I put this same statements in here like this, and let me turn this one off up here. Let's just say, yeah, I'll turn this off. So we're still going to read the input from the user, and we'll start from 10 as usual. Okay, but I'm going to print I, which is in this case is 10, and then all the way to whatever this max is from the user. Okay, so let me run this now. Again, it's asking for a positive number. We'll try the one that's greater than 10, since it's asking us to test greater than 10. So I'll put a number, 15, and it prints out 10, 11, all the way through 15, and then when I get to 16, it's false, so it exits out of the loop. Right? Just like before, there's nothing changes. It's very similar. And if I run it again, and let's just say if I enter 1, so 1 is way less than I, which is 10, so that's false, right? But watch what happens. It still print 10 before it exits out of the loop, right? Because it guarantees one iteration, one loop through it. And so when you do this, it reads the input here to the max of 1, and then it runs the do loop, goes in here. There is no condition to test here. We treat this just like a regular statement. It runs through here, runs line 25, prints I out. I was 10 up here. Prints 10 out. We increment 10 to 11, and then you test the condition here at the bottom. Is I, which is 10, less than or equal to 1? No, it's not, so it exits out the loop, and then we're done. So it doesn't repeat the loop anymore, but we already printed the I out once, right? So you run through one time, guaranteed. Okay, so it doesn't matter what the condition here it is. It doesn't really matter. It will always run one time. And so this one here guarantees it. This one does not, right? And then a question you might ask is like, so what's the difference? Why do you use this versus this at the top? Okay. So this one down here, you use it in certain situations, things like if you want to have very common example would be like if you ask write a game or a program to ask the user to guess your magic number, right? It's pretty typical. Let's say your magic number is 7, okay? And you want to test with the magic number, and you will quit the program until the magic number is equal to your 7. So we could do something like here. For example, we could say int magic number is 7. That's my magic number. Well, the user doesn't know that. The user have to guess it, right? So magic number is 7. And then the instead of max, I'm going to call it something else. I will call this. Let's just do it down here. We'll comment this out. I'll take this out. Let's do this. Copy this, and I will just comment all these out. Okay, so down here, we'll have a magic number. We'll ask the user to input to guess a number. Say, what's my magic number? Okay, they'll enter that here. And then we're going to read that magic number into here, the guess. And then we'll check in here we'll print something like yay, you found it, something like that, right? You put yay message if it's correct. And then here, if instead of increment this I, we're not going to do that. We'll exit out the loop when the magic number matches the guess number equal to the guess number, right? We'll guess num here. Okay. So inside the loop here, you will say, I only print this line out if it's true, right? So we'll say if the magic num is equal to guess num. If that is true, then print this line out to the user. Otherwise, else, right? What do? See, else, you have to read, you have to ask the user again, right? So you have to say again, put that in here again. And then we don't initialize, declare that anymore. So you keep doing that until it equals the guess number and the magic number. Okay, so let's see. If I run this, the magic number is 7, I put 8. I keep asking that until I get it right. Right? 5. And then if I put, run to error here. Okay, run to error here because there's some error in the code here. When num is equal to true, yeah, well, this is not true, right? We stop when the when the guess number is not equal to the magic number. I had it wrong. When they're not equal, then we keep doing the loop. Once they're equal, then we stop. Okay.
I do have a question.
Mm-hmm.
As you're running and as I'm running my program, how do I make the cursor always be where I want it to be? Because I notice sometimes, like when I'm running and it says enter the number, my cursor will be up on the top pane. I have to click it to be on the bottom pane.
When you run the application?
Yeah, try running it. I'll show you what you mean.
Mm-hmm.
Okay, so.
The cursor is not showing. Right.
So how do you make it?
Yeah, this is it's an IDE issue. So every IDE has different output here. So for example, Eclipse doesn't have it. Eclipse, if you click it here, you'll see that it's here. If you run it again,
but you
you'll
can
see
also
that.
Click it on the top pane, so you can't make it the cursor there.
No, yeah, it's you can't control it here. Yeah, so it will look different here. If you run this on the command prompt, then your cursor will be right here in the end of that line. If you run with in NetBeans, it'll be a different place.
Okay.
So it is different every time. Yeah, but that's why it's not really really useful. So we use the GUI to display data, right? The window. Okay, so let's just say if I enter again 5, and it's not right, so I'll enter 6, and I'll keep doing it until I get 7. And then what happens now? So I get 7. It didn't print that for me. Why is that? If magic num is equal to I wonder why it didn't let's see, 7. Yeah, that's that one. It terminates. Let's try one more time. 6, 7. Okay, if I do it 2 times, then it doesn't. This part?
The bottom, just the bottom. That's
Oh, right here?
Yeah.
Let's see when I read.
It's only printing out that again as a question, right?
Yeah, right. So typically you don't need this else part. Okay. you want to do just that, because no matter what, you want to execute that. And when you do something like this, when you find what you want, you can break out of the loop. So you don't have to go through that. You can do this as well to stop it. But what I want to show you is that the reason why we use a do loop and do while is because of these two lines here, right? In order to ask the user to input the data again, I have to retype this whole thing again down here. I do it twice. Okay, so that's not really efficient. So you want to do only one time. So you put this right in top here. Okay, and then you turn this off. Okay, because no matter what, I'm gonna run into I'm gonna ask the user every time anyway. Okay, and let's put the guest number up here. Okay, so I asked the user, when I run this loop, I'm going to ask them to get the matching number. I read it, I compare it, and then if it matches, then I'll stop. If it doesn't, it goes to the bottom here. Do they match or not? Then it goes back and asks it again. Okay, so I just write the statement here one time in the code. Whereas if I don't do it this way, if I do the do while, the regular while, I have to ask the question outside to read the input, and then if it doesn't match, I have to ask it again inside the loop here. So I'm doing 2 times. So it's repeating what I'm trying to do. Whereas this way, I could just do 1 time, and if it's a 5, I keep asking until I get it right? And then 7, we'll just X out the loop. Okay, so you don't have to do it this part here 2 times. Saves you a lot of code. This could be just a really simple example of how you can do 1 time, but you can have a bunch of code here to do something, and you don't want to repeat that again in the loop. So to do this in the while loop, you will see that I have to do it this way. You have to say, read that input here outside, and then while magic, so you do test at the top is not equal to the guess number. If that is true, then only when you run this file. So I'm going to put the statements back in here. I'll put it out to the screen, and then let's see if I do it this way. So there's no way of, if it doesn't match, if I go in here, in this case, because if I put 5 for the input here, the guess, 5 is not equal to 7, that's true because they're not equal. So it's going to go in here and then run these 3 lines of code here. And then since the magic number is not equal, it will go back to the loop, and then it goes back to the while loop. And then from here on, there's no way of telling what to do next, right? You can't tell what the user is going to do unless you output another screen message again here saying enter that output again. And then you read it again into the guess number, and then the loop goes back. Okay, so that's why you have to write it twice if you don't have this one here. Okay, if you run this now, you see that it asks for the number. If I press 7, then yeah, that's fine because it should match. But then if I have, let's just say, 5, then it goes to the loop, but then doesn't know what to do next because you don't tell the user what to do, and it can't. So they don't know what to do next. So you have to ask again to enter another number. So you would say, "Oh, sorry, that's not my magic number. Enter again." And so we do that, that many times. Whereas this way, you ask one time and then it stays in the loop, so you don't have to do it again and again. Okay, so save you those 2 lines of code, but it could be more. It's just to show you that you would do that. So this is for the purpose of something like if you want to display some data to the user first before you proceed with the next examples, then you want to use a do while. Okay, so so you present like, do you want to continue? You put in here, and then if they say yes, then you continue. If otherwise, you exit out. So it always shows that command, or that if it's a dialog box to the user, they always see that first before they continue. Okay, and so you don't have to test the condition. Otherwise, if you test it, then the user may not see that message if this is never true. Okay, so that is the difference between the two. Okay, so that's the while loop, and I'm gonna just comment all these out here, and let's do the next loop, which is the for loop. So down here, it's a for loop. Okay, this is a this is like the definite loop. Well, I mean the while too, but this loop here is very helpful. It's useful in the situation where you know the upper bound and lower bound. Okay, you know exactly how many iterations you need to go through. Then use the for loop. Okay, so I'm like up here. If we know that the max was 10, and we know that that's the maximum 10. So I know that I would loop it through 10 times. So if you don't know, then use the while loop. If you do, use the for loop. So the for loop looks like this. The head of the for loop looks like for, parentheses, and then the body of the loop. Okay. So in here, in the head of the loop, inside here, it takes 3 groups of data. So it's like 3 parameters, and you separate each by a semicolon. So the first part here is the initializer, the value you need to loop through. So like, for example, it's like the I, int I, and you want to initialize this value from 0. So I'm going to start this loop again. I'm just going to print I out to the screen. I'm starting from I is 0. Then I'm going to test my condition here. I'll keep doing this until I is while I is less than 10, and then I will increment I, the last part. Okay, so you put everything here in the head of the loop here. Whereas the while, you have to create this outside of the while loop. You cannot put it inside the head of the while loop. Okay, so and then I just basically now system.out print I. So that's much shorter. 3 lines. Whereas the while loop, you can see we have I have 1, 2, 3, 4, 5 lines, right? Okay, I need a counter. I need a counter here. I need the condition, the out, and then the increment, and then close. Whereas here, I just need everything is inside the head here, and then just print, and then we're done. The increment is over here on the same line, right? I don't do it down here. I don't say I plus down here, right? You don't need that here. Okay, so we'll put 20 here just to show that it does work. And if I run this now, you see that it prints from 1 to 20, 0 to 20, including 0. Okay, so this is very useful for if you know your boundaries. If I know that I'm going to start from this X number all the way down to up to this number here, I could again still use like the max is equal to 20, and then just say here is go to max, right? You could do that. As long as it's true, then you know that many times already to use the for loop. And you don't always have to start with 0. You can start from any number. I mean, typically you use 0 because usually you use that to loop through an array. And we'll talk about array next time. A list of data, right? You start from the 0 position all the way to the x number of element here. Okay, so I want to show this. Just put a note here. This part here is the initializer, or we call this the counter. Okay, you count, which is the I. And this part here, and put some space in here so you can see. Okay, this part here, counter, this is the condition, test, right, or test. Okay. And then this part here is just the, you increment the counter. If you don't increment, then this will never be false, and you end up with an infinite loop again, right? So you always make sure that you get out of the loop. Your condition has to be false at some point in the loop here. Okay. So so the first part here, the initializer part, is only execute one time. You run through the loop here. It's first thing is it will look at the initial values here, and then it check the condition. This is the order how this loop works. It look at the initializer. It checks for the condition. If that's true, then it will go into the body. It runs your code in the body, all of them. And then the last line, when it reaches this line 62, it's going to go back to line 60, and then it increments I. Okay, the second time around. Once that's incremented, then it goes into the condition and check the condition. It doesn't go back here anymore. This is only the first time you run through. Okay, then you check that condition. If it's true, then you repeat this whole process. Run the code, end the loop, increment, condition, run the code until it's false, and then you exit out the loop. Okay, so you want to make sure that you incremented the correct variable here. If it's I, then I have to be here. Otherwise, if you put something else, you're gonna have the same problem with the infinite loop. Okay, so the first part here, I can increment, I can set I. If you have other variables in here, let's just say I want to have something like I want to print I plus maybe J, right? You could do this. You could say int J is equal to 1, and then you print 0, which I plus J, which is 1, and then after that you want to increment J together. So when you add this together, you print it out to the screen, you see something like this, right? J is 1, I is 0, so you get 1, and then J is now 1, and then I is 1, so I mean J is now 2, so you're printing a odd number. I just solved the problem here. Wow. So you printing odd numbers here, right? So I have two variables here. I could do this, or I could move J, okay, and put it in here along with I, and you separate that with the comma, and it's the same line of text code, so you don't need the int here because they're both int, and you move that semicolon. So I have I and J in there. So I don't have any I, J outside of the code here. It's all in the same area. I have two variables to play with. And I just want to make sure that my condition, I'm testing for the I and not the J. Right? If you put J here, you might get a different result because the J will increment differently than the I. If it has a different value. Instead of 1, I could put 10 here. And then 10 would, or if I put 30 here, then those would be, if I put J here instead of I, then this is false already because J is already more than 20, and then therefore it doesn't execute the statements, right? So if I run this code, you'll see that it doesn't print, and I think it probably go to a loop. Okay, this is nothing executed. So you want to make sure you're testing the right condition here. And you can put as many variables you want here. If you want to use these as local variables inside this for loop here, then you can do j, k, other variables in here. Okay. So that is a for loop, but I mean you will rarely see this. It's not very common, but sometimes you will see that they have 3 or 4 different variables in there, and usually these are for like really complex applications, like games or really big applications like a text software or something like that. You see those variables in there, and only used once inside the code, in the loop here. And once they are done with the loop, then all these variables are destroyed, right? Whereas if you put this outside here, then j still exists after you execute the code. So you may not want that. Okay, so that's one loop. Another one, second one is that you could also do this. You can leave the first part out, and then okay. And let's just say assume that I have I is what do you have I? So this I here is local only to the inside the for loop here, right? It doesn't exist outside. That's why I is not found here. But if I initialize my I outside to be 0, okay, then I don't need to put I in here. This is only for the initializer part. So it knows that it checks in here. There's nothing here to evaluate to initialize. That's fine. It's going to go to the second part here to test the condition where I is already existed here. So that will still be evaluated, and then it will do the output in here just like I have up here, and it will still be fine. Okay, so if I comment these out,
That's why I was
you didn't see that type really fast.
You do that, I think that to ask that.
I just did like line by line really fast. You didn't see it?
No. How did you do that?
Okay. Well, let's see. Let's undo this, right? So you highlight the lines of code you want to comment. You press the Control key and the question mark,
okay.
or the /.
And then undo
So
as well.
yeah, you press it and you press it again. Okay.
Okay, so you highlight.
Yeah, highlight what you want to comment out,
Okay.
and then you press the Control key, press the / or the question mark, and you can highlight the. In this way, you do a single line comment, right? If you want to do like you see like the multi-line like this, you do that, and then you do like here I want to do that, right? You do the same thing, highlight what you want to comment out, press Control Shift, and then or it must be a different IDE. No, I forgot the command here, but there's another way. Maybe the backward slash. Yeah, I forgot what one. I'm using a different IDE, but there's another way for that as well, the shortcut to do that. So it's very common in Eclipse. I think it's also the same in NetBeans. Okay. Also, if you use like WebStorm or PHP Storm, the JetBrains products, it's all the same. So yeah, Control question mark. Okay. So very quickly to comment out your code. This is not part of Java. Okay? It's not a Java thing. Okay, so as you can see, if I run this code now, I will still have the result of 1 to 10. Okay, or actually more than that because I put 20 in the max. Okay, and you don't include the first part here because I say initialize that already outside of the loop. Okay, and if you don't want to include that here, then fine, you move it down here. You can move it down here. Okay, you increment it down here instead of here. You can still leave that. You leave that blank, and it should still work. You still get 20. Okay, so there are many ways to do it. I mean, this is kind of not normal for a loop, but you can do that. Okay, so you can take it out and do it that way, or you can take this whole thing out. There's nothing there now, and what do you think is going to happen? Yeah, it's a forever loop, right? Go for it because there's no way of testing this condition, and maybe sometimes you want to do that. I don't know for what reason, but maybe like a little widget to like a clock that would never stop, right? But still, it's going to consume your system. So, because the only way to stop this is how would you stop it? There's no condition here. Run through the loop. How do you stop it, right? So the way to stop this is you read the local time of your machine, and if the time or the date passes a certain date, and it exits out of the loop, right? So let's say you have a future time. You can read the local time, say when the day is, December 31st, whatever it is, then
2046.
break it. Put a break in there, then it will exit out the loop. So that future time. Okay, that's something you might want to do that for, but like a countdown thing, right? Maybe. Okay, so I just show you that you can do that, and it looks weird, but it will run. Okay. Something you also want to watch out for is so I mean, if you see this, don't run. Okay, let's put this back. I'll comment this out. Another one here you want to watch out for is, let's say you have the while loop. What's the time we have? Okay, 15 minutes, 20 minutes, 12 minutes. Okay, so while, if you say while I is less than 5, and you do like this, right? That's true. And you say system out print okay. Okay. And this will be fine if you run this now. You should say okay 5 times or that many times, right? See, it's an infinite loop. It goes forever now. Because I have no way to stop that. And again, you run into this issue quite often because of the while loop. You've always forgot to increment the I, right? So when you run this in the IDE, it runs forever. You're lucky because we run an IDE. You can stop this. So if you do this, you click the stop button here to stop the infinite loop. Okay. If you were to compile this program and you run it, you give it to somebody else to run it, and it will crash the system. Okay. So don't be mean. Hey, you want to run this application? It's pretty cool. I created. Okay. All right. So now that should be normal, right? It runs there 5 times. It prints out okay 5 times, and then we're done. Okay. Sometimes you forgot and then you accidentally put a semicolon here, and you would think that this is part of the while loop, right? And it looks just a regular while loop. It looks good. There's no error, no red squiggly lines. You don't see those. When you run it, what is going to happen? So infinite loop. Now I can't stop it. Okay, because I don't have any output, so I can't stop it now. See the spinning thing? I hope did it stop? Yeah, I hope maybe it did. I don't know. Yeah, I guess it did. Okay, so this is one of the pitfalls you want to watch out for. Don't put a semicolon here because we learned last time that you can put color braces around your code, and that's a block of code, right? It's legal in Java. And just because you have it under the while loop, it doesn't mean it's part of the while loop if you put a semicolon here. So so you want to make sure that this really is part of the while loop, the body of the while loop. Otherwise, you have a blank loop. Okay, so that's something you want to watch out for. Okay, what else do we? Am I missing something else in here? So we have the shortcut. Yeah, the shortcut here, I think you know already, right? The plus equal and the minus equal. Okay, like here, the plus equal minus equal. That just means that, when you add something, like for example, I put total here, int total equals 0, and then instead of OK, I would put like, well, I is less than 5. Then I want to say total is equal to total plus I, right? And then I can put the total here out. And the total is equal to total. Okay? So you print that out, it will have like 5 and then 6, no, 0, 1, 2, 3, 4, 5, and so forth. So you get total 0, 1, 3, 5, 6, because you keep adding I to the total here, right? So the shortcut for this line is, instead of doing that, I could just say total plus equal I. Okay? From this, this to that, they mean the same thing. Okay? So that's exactly the same as that. So we can see 1, 3, 6, 10, and then if I run this, again, you see that you get 1, 3, 6, 10. Okay, so this is a shortcut for the I. You can do the same for the minus. If you want to a minus, then you can do that. I minus 10. It looks just like that syntax. And it will go into a negative numbers. You can do for the multiplication. Okay. And you'll see it's all 0 because 0 times something is always 0. And then you have the division as well. You have a divide by 0 rule, so it crashed. Okay. So that's what it talks about, the shortcut. The only thing is that if you do this, then this total has to be on the right side, and then minus or times something. So this I here has to be, and that looks like that if we write it, because I could have I plus 1 times 5, whatever it is, right? So this whole thing here has to be subtracted by total, or plus by total, or multiplied by total, in order for you to use the shortcut here. Okay, you can't put like suddenly plus total here and you expect this to work the same way. It doesn't work that way. Okay, so it has to be the total itself, whatever this variable is, plus or times or divided by the whole set of data on the right side for the shortcut to work. And you'll find this very, very useful, and you'll probably end up using a lot of these in your code when you do this type of multiplication. This is for addition, right? You also do for string. String also has the same idea, right? So if I have, if I say string str, let's go to high, and then later on down here I will add string again. I can say string plus equal there, right? So you're concatenating the string like this, instead of saying is equal to string plus that. Okay, so you can do the shortcut method to shorten your code. So that is the same as okay, they are equivalent. Okay, so that's the shortcut. We learned about that. The nested loop, nested loop here again, it just means you have a loop inside another loop here. So I could do like the while loop here, and then I could put the for loop inside that loop. I could do this and put it inside the while loop here. Okay, and then you have a nested loop inside another loop. That's all it's saying. You can have a nested loop inside another loop. We could call this one maybe like K or something. Okay, so I have a nested loop. For loop is nested inside the while loop, and I can put the while loop inside the for loop, and so on. You can go as deep as you want. It doesn't really matter. Okay, just like the if and else block, like the if and else and the switch block, you can nest those together as well. So the same way you would do that here. I think that's about it. And so on the exercise I ask you to do is number, what do we have? The homework assignment is to do all that to get you used to that. So 3, 6, and 13. Okay, so number 3 is this one here, right? Application to ask the user to type an even number or the signal. Okay, the signal value is the exit value. Okay, so if you hear the signal value is always a value that will terminate the loop. Okay, so it could be anything. Here, it just say 999 to stop. If you usually say enter a -1 to stop the loop, or enter a 0 to stop if you want to stop this loop. Otherwise, it will keep looping through the whole time. So that's the signal value. It's an indicator to stop the loop. So you write that to ask the user to enter a number. Even number, and if that it's an even number, then you say it's good job. Otherwise, if it's an odd number, then you ask the user to enter again until they enter 999 to exit out of the loop. Okay, so that's pretty straightforward. Number 6 asks you to display a perfect number. Okay, the perfect number from 1 to 1000. So a perfect number is described here is a number that is divisible by these numbers in between, and all these numbers also, if you add them up, you get the same number as the magic number, right? So that's called a magic number. So for example, 6 is divisible by 1, 2, and 3. And if you add these numbers 1, 2, and 3 together, you get 6 back, right? So that's a magic number. But 12 is not, because 12 is divisible by 1, 2, 3, 4, and 6. If you add them up, you get a different number. You get like a 16. So 16 is not the same as 12, so therefore it's not a magic number, so it's false. So have fun with this application, okay? So how do you get the? So how would you solve this problem? Okay, these are your divisible numbers. So instead of doing this, use the modulus. Okay, use the mod. If you say 6 mod 1, if you get a remainder 0, then that is divisible by 1, right? So 6 mod 2, you get 3, remainder 0. So that's good. 6 mod 4, so 6 divided by 4 is 1 with a remainder of 2. So if the remainder is not other than 0, that is not divisible by that number. So you move on to the next number, right? So you loop for like for 1, I is 1, and then while I is less equal to 1000, you check for I. So 6 divided by 6 divided by I. Well, not 6, but whatever the number is divided by I. If it's divisible by that, means if you do a mod, you get a 0. Then, right, the mod, right? You know the mod. So x. Okay, so we put int x if it's 6, right? So if I say no, not x. So here, if 6 mod is the percent sign 2, 3, then the answer is 2 with a remainder of 0, right? So we get a 0. Okay? So if you run this now, you get a 0 for the remainder. So therefore, 3 is divisible by 6 is divisible by 3. If you put 2, then you get the answer of 3 with remainder 0. So this remainder here is returned by this modulus symbol, and you get the answer of 0, and so therefore it's divisible by 2 as well. If you put 4, then you get a number of other than 0, it's a 2 with the remainder 2, so therefore this is not divisible by 4. Okay? So that's how you determine whether a number is divisible by another number or not.
But 6 is a perfect number, you said, right?
In this case, 6 is perfect because 6 is divisible by 1, right, with the remainder 0. Divisible by 2. So if you get 1, so you get 1. And then 2 is divisible by 6 divisible by 2, so we plus 2. And then 3 is also divisible by 6 is divisible by 3, you plus 3. And 4 is not, so therefore it's not. 5 is not. 6 is 6, or it's into itself. So if you add them up, you get a total of 6. So the numbers that are divided into that value, what that value is, okay, if you add all those numbers, you get the same number back as the number that you want to divide into, then that's a magic number. Yeah? So if it's like, if it's a...
We have to all the numbers between 1 and 1,000?
Yeah.
Yeah, really, is this where we just Google Java perfect numbers?
No, so you loop this through, right? So this example here, you just loop it through like this. I'll show you here. So maybe I'll show you this part so you know. You say for int I is from 0, or you can start from 1. Doesn't make sense. So I is less than equal to 6, and then I plus plus. Okay. So you need to store the value of I. Let's do a different value. Let's put m here. N. I think I used I up there already. So up here somewhere I have another end here for total. 0 first. Or those values, right? So we put total 2 here. So you can say if so this is your number here, right? So if it's 1,000, this will be 1,000, right? We're just doing for 6. It's 6 here. So if 6, let's do this. Int magic number is 6, right? We put the m in here. So you could say if mn mod n, which is the counter here, if that is true, then we're going to say total 2 is equal to total plus n. What happened? Type mismatch. Okay, yeah, why is it a mismatch? Oh, is equal to 0. Okay? You test this condition. If this one here divided by that, you get a remainder of 0, then it's a magic number. It's divisible by this number n, and then you add a total to that. Okay, so you could say like, then system out dot print the magic number of n. You put a space here, so we know that is space. Something like that, right? We'll see if that works. Okay. So we and let me turn this off here for now. So, and then we check for the total. Once we are done with the loop, outside here, you can say if total 2 is equal to the magic number. If that is true, then you want to say the magic number n, 6, is a magic number, right? Otherwise, it's not. Right? So else, say, is not a magic number. Okay, so we'll see that is not a magic number because I included the 6 here. So you don't want to include the 6 here. Just say up to 6, not inclusive. Okay, so you can see that it's a magic number. Put L in here. Okay, so we have, I don't know why it's not printing that. So I have 1, 2, 3, 6. Okay, they are divisible by 6. And then we'll say, because it's divisible by 6, the total of that is 6. And that is equal to our magic number. So therefore we say it's a magic number. So it's a magic number. So 6 is a magic number. Otherwise, it's not. So if you were 1,000, you just put 1,000 here, right? Pretty much. And then you see if that's a magic number or not. I'll let you figure that out. Okay? All right. I'm sorry, went a little bit over the time, but if there are no more questions, I will see you next week.